Lesson 3B, functions. The objective of this video is to identify and evaluate functions. So first we want to recall that a relation is a rule that kind of relates two quantities together. So that's basically our ordered pairs, our x and y's. The domain is a set of all the input values, so like all the possible x values that you can get. The range is a set of all the possible y values, your output. So a function is a special type of relation in which each element of the domain is paired with exactly one element in the range. So the domain is very specific and it can't be going to two different things. That will make it not a function. If you have a graph, you can visually determine whether it's a function or not using the vertical line test. So if you're passing a vertical line through the function or whatever's graphed and it's hitting the function at two different spots like a circle, it is not a function. But if you're passing a vertical line and it never hits in two spots at the same time, it is a function. So here we just want to practice whether something is a function or not. So for my first image A, if I pass my vertical line through the graph, I'm going to hit this graph in two different spots, so it's not a function. So A is not a function. B, if I pass a vertical line through it, again, I'm going to be hitting it at two exact spots at the same time, so not a function. C passes the vertical line test, so it's a function. D also passes vertical line test, so it is a function. For my tables, I have to determine whether my x is going to exactly 1 y. So my x's, I have 1 going to 2 and 1 going to 4, so this will make it not a function. So E is not a function. For F, my x's are not repeating, so everything is going to separate y's, so function. For my mappings, my 3, my 5, and my 7 are going to different things, so function, they are independent from each other. For H, my 1 is going to two different outputs. It's going to -3 and to +3, so this makes it not a function because it can only go to 1. For my remaining, I can use my ordered pairs. So are my x values independent, going to exactly one thing? So I'm not repeating any of my x's, so I is a function. And for my last one, I am not repeating any of my x's, so J is a function. We also want to know how to evaluate a function using something called function notation. So the letter on the outside of the parentheses is basically the name of the function. We usually use F, but we can use other letters like G, H, I, etc. And then whatever is inside the parentheses, that is your input. So if we're talking about x's because we're using the variable x, then this would be read f of x. If we're using the variable n because that's the variables we're using in this specific problem, then my function would be f of n. And then the output is whatever your function is going to give you once you plug in those numbers. So remember, f of x is the same thing as y. Okay, so in my problem here, I have my function at h of n, and I want to find h of 8, meaning I will replace letter n with the number 8, but keep everything else. Then use your order of operations to simplify these expressions. So we are going to get 104. Now we are going to replace our function n with n squared. So I have this n here that I'm going to replace, but then that n that I replace with n squared is also being squared. So now I'm going to simplify this expression. So when I have a power to a power, I multiply. So really I have n squared and then 5n squared. So I'm not actually going to get a number. I am just simplifying this. And that makes sense because I'm basically just plugging in another variable into this function. We can also use this idea to evaluate piecewise functions. So we kind of have to follow the constraints given on each piece of this function to determine which one we're going to plug into. So for the first one, if I want to plug in -2, well, I have to determine which of these three am I going to use. Well, I am going to use the middle one because -2 falls in between -4 and +1. So this is where -2 would be a true statement. So I'm going to use this one. So this is what I'm going to use. I will replace the letter X with the number -2. So that will give me -4, and the absolute value of -4 is +4. In order to do -8, again, we want to determine which one we're going to use. So I'm going to use the top one because -8 is less than -4. So if I'm going to use this one, I will replace X with -8 and simplify, giving me +8. And for the remaining one, 6, well, 6 is greater than 1. So I will plug into -3 over X. So replace X with 6 and simplify. So I will get a -1/2.